Hello. If you can hear me or see me, please just post a thumbs up or say hi in the chat. I can see a few people joined. Hello, hello. Sorry about the mix up for whatever reason. The original link would not allow me to, it wouldn't work. It was not connecting, so I had to exit and then it wouldn't let me back in. It only had me as a spectator in my own screen. So I apologize for that, but we are up and running now. If you can hear me or see me, please go ahead and just drop a hello or a thumbs up or something in the chat, please. I may just peek in Canvas real quick to see if anyone is messaging me, asking questions, since I know I had to change the link. Okay. Hello. All right, so we're going to go ahead and get started. I want to respect your time. Thank you for joining. Hopefully, we'll have a few other people come in. We've got, I've on only 2 people. I think what I may do is join the other chat on a different computer so that I don't bail out of it. So give me 1 second. I just want to make sure everyone sees that we switched over. Okay. All right, if you can have your review packets ready in the meantime, so we'll get started straight away. I think I started the majority of the review packets with, I think I started the majority of the review packets with all the classes. So what I may do is, to make it easier, is just go backwards. And then that way, if a student doesn't have any questions once they've gone through their review packet, we can just go ahead, they can go ahead and log out if they don't have any questions. So just respond to this announcement really quick. And hopefully it closed out, but if it see, it still says it's waiting for me. Okay. Please go into announcements. Okay. All right, so we're going to go ahead and get started. There were a couple other people waiting in the other one, but I did notify them. So thank you so much for joining. I hope you guys are having a great evening. We're going to start with question 45, and I'm going to work my way backwards. So the first question is to compare mass and weight. So when comparing mass and weight, mass is the amount of material an object contains. So for example, this bottle of water, okay, not only do we have the bottle, but we have the water inside the bottle. If it was halfway full, it would have much less mass than if it was completely full. So it's the amount of matter within an object. The weight is gravity's impact or influence on that object. So weight is measured by a scale, and mass is measured by, well, weight is measured by a scale and mass is measured by a balance. Okay, so how does gravity affect mass and how does gravity affect weight? Gravity does not affect mass at all, but it does affect weight in that weight is gravity's impact on mass. What kind of force is gravity? Well, gravity is a force of attraction. It is a pull specifically. And what two factors impact gravity? Gravity is impacted by the distance between two objects and the size of the objects. So the larger the objects, the greater the gravitational pull. I'm currently on question number 43. I started with 45 and I'm going backwards. And the live video will be posted as well. So if you missed the questions in the beginning, you'll be able to go back and take a look. So getting back to that size of the objects. So the larger the objects, the greater the gravitational pull. The smaller the objects, the lower the gravitational pull. The further away the objects are, the lower the gravitational pull. The closer the objects are together, you're welcome, the greater the gravitational pull. Does anyone have any questions on what we've covered so far? Okay, I'm going to go ahead and continue. All right, so number 42, draw a diagram that shows an unbalanced force. So if you were looking at an unbalanced force, one of the things you would see would be, let's say, a block with two completely different forces on one side than the other. You can have a block with one force pulling on one side with nothing on the other side, or you can have, let's say, a block and you have a 10 Newton force pulling this way and a 20 Newton force pulling that way. As long as the sum of the two forces, the negative and the positive, which indicates opposite directions, as long as those two don't equal zero, it is an unbalanced force. Draw a force diagram that shows a balanced force. So now that's the opposite. If you have two objects that are, if you have an object and you have a force going on one side and the identical force going on the other side. So for example, a box that has a 10 Newton force pulling to the left while it has a 10 Newton force pulling to the right. That would be a balanced force. The sum of the forces is zero and that object would not move. I apologize if you hear a whistling noise in the background. My dog is right here crying, so I apologize. He's not crying because anything's wrong. He just wants food. So number 40, what is the total net force if an unbalanced force acts on an object? The total net force is zero. Oh, I'm sorry. I apologize. What is the total net force if an unbalanced force acts on an object? The total net force is any number that is not zero. It can be negative and positive. And remember, I said it could be negative because the direction of the force is indicated by a negative or a positive. If it is negative, it is either going to the left or down. If it is positive, it is either going to the right or up. What is the total net force if a balanced force acts on an object? If a balanced force acts on an object, this is number 39, the net force is zero. Net force, what is a net force? Net force is defined as the sum of all of the forces acting on an object. Any questions so far? Okay. If you have any questions, feel free to pop it in the chat and I'll take a look. All right, so create a Venn diagram comparing balanced and unbalanced forces. describe how each can affect an object in motion. Okay, so a balanced force, we know when objects have forces that are equal in size and opposite in direction, that is a balanced force. Okay, in the unbalanced force side, when objects have an applied force that is unequal in size, they can be opposite in direction, they can be going in the same direction. Okay, so the balanced force on that side that's equal and opposite. For the unbalanced force, it could be the same side or it could be the opposite. A stationary object in a balanced force will stay at rest. A stationary object, when exposed to an unbalanced force, will move in the direction of greater force. A moving object, when a balanced force is applied, will continue to move with the same speed. An unbalanced force will change speed or direction. And a net force is 0 on a balanced force, and an unbalanced force, the net force is non-zero or not 0. Okay, so that was the Venn diagram for number 37. All right, so number 34, draw a graph that represents an object that is moving at a constant speed. So an object that is moving at a constant speed, you would have a graph starting at the 0 point that would be moving in a straight line. And number 35, draw a graph that represents an object that is accelerating. So there are 2 forms of acceleration. A lot of people don't realize this. Accelerating means changing speed when we're talking about it in science. So a graph that is accelerating in the positive direction would be parabolic going that way. And if it is accelerating in the negative direction or decelerating, it would go like this. Okay? Questions? All right. So draw a graph that represents the following motion: a person walking 5 meters in 10 seconds and then moves 10 meters in 4 seconds. So if they're moving 5 meters in 10 seconds and then 10 meters in 4 seconds, they're accelerating. So they would first have a straight line that would kind of be like this, and then it would have a rapid rise, so it would go up like that. So, and it looks kind of like that. So if you just want to see what those look like, the page might be backwards for you. Looks fine to me, but okay, that's what those look like. Any questions so far? Again, if you have any questions, you are welcome. There is someone waiting in the other live. Sorry. Let me see. I'm just checking to see if anyone's looking for me while I am doing this. Okay. All right. So we are now on question number 33. What is the equation for calculating speed? Oh, do you want to see the graphs again? Okay. So I'll move it up in a second. First, let you see the top. Oh, there we go. This is counterintuitive for me. Is that okay? It's not time yet. Okay. You're welcome. All right. What is the equation for calculating speed? Speed equals distance over time. If a car travels 400 meters in 20 seconds, how fast is it going? Okay. 400 meters is the distance divided by 20 seconds, which is the time. It is 20 meters per second. If you need to get to class 200 meters away, you can only walk In the hallways, about 1.5 meters per second. How much time will it take for you to get to class? So you have 200 meters, which is the distance, divided by the time, which is 1.5 seconds. You would get 133.33 seconds. Now, I know it has a tendency of going 33333, but it would be 133.33. How far can you get from your little brother with a squirt gun filled with paint if you can travel 3 meters per second and have 15 seconds before he sees you? So 3 meters per second divided by 15 seconds speed. Oh, I'm sorry. You're traveling distance at this point. I apologize. So you would have to rearrange your formula. Okay, so its distance is speed times time. So 3 meters per second squared times 15 seconds would mean you would be able to get 45 meters prior to him seeing you. Okay, so that was number 33. Are we good with that? All right. Sorry. My printer's not behaving. I apologize. Excuse me. Okay, I apologize. I had to turn that off. So, number 32. What factors affect the amount of friction between two objects? The surface type and the mass of the object. The surface type will impact the friction because different surface types will have what we call different coefficients of friction. For example, metal on ice will be far more, they'll be far more slippery than concrete on concrete, for example. So the frictional forces between the objects are different. Okay. List at least 2 ways to increase friction between two objects. You can change the surface type or you can change the mass. So if you increase the mass of the object, it increases the pressure that is being put on the object. And then with that, it will cause an increase in frictional forces. Okay, so the increase in mass or the change in surface. By the way, we are on question 32. If you came in later, I did see the numbers change a little bit as time went on. Feel free to go ahead once the live is over and open up the video. We're going backwards with the questions right now, so that you don't have to scroll through, because I know we didn't get to question number 45 with any class. So provide 2 examples of when we would want to increase friction and when we would want to decrease friction. So examples of increasing friction. If you're driving, you want to increase the frictional force. You don't want to hydroplane. Playing sports, if you are running on a track, you would like to increase the frictional force so you don't lose your footing. Or if you're playing soccer, you don't want to slide in the grass, so on and so forth. Decreasing frictional forces, decrease frictional forces. If you're ice skating, you don't want to increase your frictional force there because then your foot will stick in the ice. Flying, decreasing frictional forces will actually provide for a much better glide with the airplane. What causes friction between 2 objects? Friction is a force resisting motion when an object is in contact with another object. This resistive force is caused by the surface roughness and the contact of the material. So molecular attraction or adhesion between materials and deformation in the materials. So depending on, for example, if you have a molecular adhesion, for, you've seen sometimes if you have like a drop of water between 2 objects, it could increase the adhesion between the objects. Glue, for example, will increase molecular adhesion. But when you're also talking about concrete, for example, that surface will have a tendency of creating a bit of a grip, which will increase the adhesion between the two objects. All right. Any questions? All right. So we're in the Venn diagram for types of forces. This is number 30. Create a Venn diagram comparing contact and non-contact forces. Include two examples of contact and non-contact forces. So in contact forces, you have interactions with objects that touch. You have a normal force, frictional force, drag force, spring force, and applied force. So by spring force, we're looking at like a spring scale, a rubber band, or something like that. A non-contact force, you have magnetic force, gravitational force, and you have electrical forces. What major types of forces could be applied in the following scenarios? So in a tug of war, you have applied force, contact force, and frictional force. Okay, applied force, you are applying a force to the rope. A contact force, you're pulling the rope. A frictional force, the frictional force between the rope and the hands. Skydiving, gravitational force and frictional force. Yes, there is some frictional force in the air. That's what tends to slow down the skydiver. Separating metals and non-metals, that is a magnetic force. And bungee jumping, that is a gravitational force and an elastic force. Any questions so far? Stitch is wonderful. I have Stitch and Angel. I'll show you guys at the end. Remind me. And I got baby Stitch behind me. Oh, I got to go the other way. You probably see him sitting there. That would be my squishy Stitch. Explain the energy transformations that occur when a flashlight is turned on. So you have chemical energy in the batteries that is transformed into electrical energy and then into light or radiant and thermal energy. Okay. Define and give examples of convection, conduction, and radiation. Oh, hi. Hi, Leah. We are on that was question 26. I guess I should have gone to 28 and backwards, but you get used to reading from the top of the page, so I apologize. Let me get to 28 and then I'll go backwards again. So for number 28, a hot cup of coffee is placed in a room. Describe the flow of thermal energy as the coffee cools. Draw arrows to show the direction of the thermal energy transfer. So thermal energy goes from the inside of the coffee cup outside to the environment. So you will have arrows drawn from out the cup, which I think was already in your picture, if I recall correctly. Unless I was just looking at mine and it looked like it was in yours. So define and give examples of convection, conduction, and radiation. This is 27. Radiation is heat transfer through electromagnetic waves. Okay, so energy coming from the sun. Okay, a fire or a microwave. So those are, microwave is an electromagnetic wave. Conduction, heat transfer through direct contact. So for example, a pot on the stove, the pot gets hot because you turn the stove on. Convection is heat transferred through fluid or through air, liquid or a gas. So boiling water or a lava lamp. I did this in class. We had little dots from when you hole punch papers and we put them in a container of boiling water. And as the water started to boil, you were able to see that the dots started moving like this. It created a convection current in the water. So that is an example of that. And number 26, I went over, but I'll briefly review it again. The transformations of when you turn a flashlight on is chemical from the batteries is transformed into electrical energy and then into light and thermal energy. Okay. Any questions so far? All right. All right. So we're looking at number 25. So define and give an example of each form of energy listed below. So thermal energy, the total kinetic energy of the particles in a substance. Okay, so thermal energy is it's heat. It's the measurement of the particles of the substance, of the energy of the particles in the substance. An example of that is a hot plate. Nuclear energy is the energy stored in the nucleus of an atom. Okay, so when we undergo atomic fission or atomic fusion, that energy is released. And a nuclear reactor would be an example of that. Chemical energy is energy stored in bonds of atoms. So food, for example, that's one example. We talked about lithium carbide batteries in class. So the lithium carbide battery, when a battery is losing energy, when it's breaking apart its bonds, when you look at your phone and your battery life is dying, it's because it's breaking apart all those bonds. That battery life is telling you the percentage of atom or the percentage of molecules left to separate to release that energy. When you plug in your phone, it reverses the chemical reaction and those bonds are restored. That energy is restored in the bonds, and then we start all over again. Okay. Mechanical is the sum of potential or kinetic energy associated with the motion or position of an object. That is a pendulum. That's an example, a pendulum. So you see it goes like this and like this and like this. That's a pendulum. When we went over the test questions, you could see that. By the way, those of you that have come in late, I will be posting this video at the end of the live. You are welcome to take a look. We started with the questions and we worked our way backwards. So you can catch up with us here now and then go and watch the beginning again to get any questions that you may have missed. Sound energy is energy from the vibrations of an object, music from a radio. Okay, radiant energy is energy from electromagnetic waves or the sun. And the example is sunlight. Electrical is energy from moving electrons. A wall outlet is an example of that. You even have static electricity is a good example of that as well. Elastic energy is energy from stretching or compressing. A spring or bow and arrow are two great examples of elastic potential energy. Explain how potential and kinetic energy are related. That is number 24. As the amount of potential energy decreases, the amount of kinetic energy increases and vice versa. So they have an inverse relationship. Use the diagram above to explain how energy is conserved during a roller coaster ride. Okay, so I'm going to do 22 and 23 back to back. So for number 22, if you look at your review guide, you have a roller coaster. Okay. Hi, Andrew. It is so good to see you. I miss having you too. I don't know who M4X Loves Blue 32 is. But welcome. Okay, so I'm going to show you, you have the greatest kinetic energy at B and the greatest potential at A, and the energy transformations that occur as you go. Oh, hi, Max. So as energy goes, as the cart goes up, you increase in potential, decrease in kinetic. As it goes down, you decrease in potential, increase in kinetic. However, the reason why you see that this is lower is because as you undergo the potential and kinetic energy transformations with the change of height, you are also having the conversion of sound and thermal energy. That takes away from the total amount of energy that is available to be converted back and forth between kinetic and potential. So you never have enough energy to go up here. Hey, Kyla, welcome. Okay, So the total amount of energy in the system remains constant, but you're converting some potential energy to kinetic or some kinetic to potential, but you're also converting it to sound and thermal energy, and that energy is part of the total energy of the system. Okay? Questions so far? All right. If you have any questions at any time, please feel free to pop it in the chat. And again, anyone who came in late, you'll be able to see the rest of the stream when we finish. It will post, and you'll be able to look at any of the questions we've already done. We are working backwards. So I'm on question number 21 now. For each type of electromagnetic radiation, provide an example of how you would encounter it in your daily life. I hope that's a good thing. I hope. So, visible light, seeing objects around you. Ultraviolet light can cause sunburn. Also, we use ultraviolet light in the classroom when we put the goggle cabinet on to, oh, well, thank you. Oh, okay. I appreciate that. Thank you. When you turn the goggle cabinet on to sterilize, that is using ultraviolet light. Infrared light, we use it in a remote control. Okay, it's also in our cell phones. We use it in when we utilize night vision goggles or when we're using it to detect heat. X-rays, we use X-rays not only in a place like the airport. Hello. We use X-rays in places not only like the airport, but we also use them as in the doctor's office. Okay. So primarily used in the doctor's office, but they also X-ray things as well to make sure you don't have anything you're not supposed to have in your luggage. Okay. That sounded, you okay there? So number 15. Hi, Kaylee. If you start the motor of a boat, who would detect the sound of the motor first? A friend sitting on the shore of the lake or a fish swimming along the shore of the lake? So the fish that is in the lake is going to hear the sound before whoever is sitting on the shore of the lake. And that's because sound travels through a more dense medium than a less dense medium. Okay, so explain why a satellite orbiting the Earth could use radar to detect objects but not sonar. Sonar utilizes, what's an example of visible light? Everything you see around you. The only reason you can see it is because of the visible light spectrum. So everything. Any colors you see is an example of visible light because it's the part of the visible light spectrum that's being reflected. So the example that they gave, I'll tell you what they gave as an example as soon as I can find that page. Oh, it's over here. Seeing objects around us. That's literally the example the district gave. Where was I? Yes. Okay. So sonar utilizes mechanical waves to be able to transport, to be able to view objects. However, since space does not have any particles, mechanical waves cannot function. So sound waves don't travel in space. You're welcome. Why does sound travel faster through metal than through air? Metal is far denser than air. Because metal is denser than air, the particles, the waves have particles to transfer on, whereas with air, it takes longer because the particles are further apart. Oh, thank you, Valentina. I appreciate it. Why does sound, okay, this is number 13. Why does sound travel faster? Oh, we just did that. I apologize. Number 12. Okay, so the first one, the one where you have the arrow pointing down and then going through the surface. The first one, that is transmission. And then the second one, you have an arrow coming down and another one coming up. That is reflection. The third one, you have an arrow going down and then angling in. Chances right here. That is refraction. The fourth one, you have a bunch of arrows. That is scattering. And the fifth one, you have an arrow going in and then nothing else going anywhere. That is absorption. Okay, so it's CEBAD. Okay. And again, if you have any questions, please feel free to pop them in and I'll answer them as they come through. All right, the law of reflection states that when light strikes a flat surface and it is reflected, you can draw a line perpendicular to the surface so that the angle of incidence, light moving towards the surface, and the angle of reflection, light moving away from the surface, will be equal. To be perfectly honest with you, I'm not sure. Well, thank you. To be perfectly honest, I'm not sure. We're not allowed to see the test. And now that the test is actually completely online, I will never have access to the test. So I've never looked at a test. I know what students have told me in the past. One of the things students have told me, which is why I went over a lot of the test questions, is that many of the test questions seem to either be mimicked or they yes, it's on School City. So either the test questions are mimicked or maybe some test questions were pulled. I can't confirm that one way or the other. I just get my information from people who've taken it. They said that the review guide was helpful. So I'll give you everything I can because this covers the main concepts of the topics. My recommendation is to please, please, please read the questions carefully. That because a lot of times people have gotten questions wrong, just not because they didn't know the concept, they just didn't read the questions completely. So, okay. So the law of reflection states that when light strikes a flat surface, it is reflected, and you can draw a line perpendicular to the surface so that the angle of incidence, the light moving towards the surface, and the angle of reflection, light reflected away from the surface, will be equal. If the angle of incidence, theta 1, is 22 degrees, what is the angle of reflection, theta 2? So if the angle of incidence is 22 degrees, then the angle of reflection will also be 22 degrees. What was what? I just read what the paper said. I'm sorry, my husband is commenting in the background. I apologize. Oh, Lord. What factors determine society's willingness to change to more eco-friendly sources of energy? This is number 10. Well, data, okay, looking at how it impacts society, new technology and materials, lack of resources. There are people saying hi, dear. He says hello. I don't know if you can hear him from all the way over there, but okay. So lack of resources. For example, if you live in Kansas, it might be windy. Okay, but go away. Go away. Okay, this entire review is devolving into nonsense. Okay, so data, new technology, materials, lack of resources, those are a couple of things that would impact it. The biggest thing, cost, is a huge issue when people are trying to get into eco-friendly materials. They can't because it's expensive. I mentioned in class earlier today that it costs $26,000 in some cases to put solar panels on your house. Not everyone has $26,000 around to help them save money on their electric bill every month. When you have, yes, we can use solar panels here, but it's not windy enough here to use a wind turbine. Or like I mentioned, in Seattle, you're not going to use solar panels. Or if you're in the middle of the state, you're not going to be able to use hydroelectric power. So the availability of certain resources in certain areas would make it difficult to do that. I think so. I think doing that and paying attention to some of the concepts we went over on the test, I think it'll help you do really well. I have faith in you. How does science and society affect each other? We talked about this. Well, maybe not 3 a.m, Jordan. Thank you. Please don't do that. I would feel terrible. And you have another final tomorrow too. Science and society. So we request information of scientists when it comes to things like building new. Hi, Aubrey. Besides speed and mass, the thermal energy formula that we used, anything that's in the book, once we're done here, what I'll probably do is go ahead through the book. In fact, I have a copy of the book here. So towards the end of the live, what I'll do is grab a copy of the book really quick as soon as I can figure out where it is. Grab a copy of the book and just flip through the pages really quick and see what formulas we have, and I'll list the formulas here. So I'll grab them for you. There weren't that many, but I know there were the energy formulas, and then the gravitational potential energy formula, the kinetic energy formula, those. So science impacts society by making requests of scientists. For example, when people get sick, they need vaccines or new medications. When we needed a response to energy, new ways to be able to harness natural resources. And you're very welcome, Aubrey. All of these different ways where we request things of scientists. I like to say all the time, math and science are married and their daughter is engineering, because all of these are intertwined in order to prepare. 1 second, someone is waiting in the live. They're not seeing that there's a second link. A hypothetical scenario. Oh, that I do know. Okay, I think I missed a comment somewhere. Okay. All right. So let's see. What are some examples of models we've used in class? We've used so many models in class. Okay, we've had some 2D models online. Anyone who came to the review sessions, for example, the HR diagram. I think I went over the HR diagram in class as well when we were studying stars. That is a 2D model of the relationship between temperature and luminosity of stars and the star life cycle. When we were looking at incandescent bulbs, a few of you, hi Gabriel, thank you. The incandescent bulbs that you were checking how the thermal energy, how inefficient it was because of its thermal energy transfer. All of the ramp stuff that we did, whether we were doing collisions or we were doing speed or we were doing the impact on mass or we were doing the impact of the braking distance, or when we looked at the center of gravity, all of those are examples of models. Now, all models, the purpose of the models is to help us see something that is too large, too small, too fast, too slow, or otherwise can't be seen by the naked eye. So it could be because it's inconvenient to see it because it takes way too long, it happens too quickly, it is too big, like space, it is too small, like the atom or a cell. It's inconvenient to see. For example, in life science, any model of the human body, we can't exactly just open up people, they won't ever be the same again. So we have to have models of what goes on in order for us to be able to explore those aspects. Make sense? Okay. Okay, the limitations, they're not to scale, they're not exact. They may not be able to show us certain aspects. What should scientists do if their hypothesis is not supported? Okay, they need to report the data. Once they report the data, they can examine it, or well, they can examine, report their data, and redesign their experiment after reviewing their results to see how they can approach their data. When graphing variables, which variable is on the y-axis and which variable is on the x-axis? The dependent or responding variable is on the y, and the manipulated or independent variable is on the x. When carrying out a scientific experiment, the outcome are more valid when the results of the multiple trials are consistent. If another scientist carries out the same investigation and gets the same outcome, the results of the experiment are even more valid. In your own words, distinguish between repetition and replication. Replication is when someone else is performing your experiment. Repetition is when you repeat your experiment more than once. What do you need to consider when conducting a scientific investigation to ensure your results are reliable? You can only test one variable, so you only have one independent variable. Everything else has to be constant. You're utilizing multiple trials. Having a control is a good idea so you can compare your results to what would normally happen in nature without whatever you're testing. Describe an investigation. This is number 3 now. Describe an investigation that could test force strength and identify the independent and dependent variable in your investigation. So I showed this to a few classes today, but there is a YouTube video on activity 81. But basically, you have the block that you've seen, the block that we used in class. There were 2 metal pieces that were put on it with a rubber band. And when we put those metal pieces with the rubber bands and we put a force meter, and you're able to move the force back and forth to see how mass impacts the amount of force that's needed to move the block. That was part of the experiment. There were a couple of other parts. We're seeing the difference between a balanced and unbalanced force, where if you have the 2 force meters that were being pulled at the same time at the same force, you would notice the block didn't move. But then if you had one that was pulled at a greater force, you would see that the block would move. The independent variable is the amount of force applied to the block, and the dependent variable was the resulting motion. If you pulled an object with an unbalanced force, the object will move more in the direction of greater force. That is one possible hypothesis. Okay, we're down to the last 2 questions. Describe an experiment that tests speed effects on collisions and identify the independent and dependent variable in your experiment. Use experiment from 76. So the height. No, there will be no questions on the periodic table. That was first semester. It's only everything we've covered from January until now. So for the independent variable, it is the ramp height, and the dependent variable is the distance the block moved. So nuclear energy is the energy in bonds. So, or in the nucleus, excuse me. I just mentioned chemical energy, scratch that. Nuclear energy is the energy that is within the nucleus of an atom. So when you undergo nuclear fusion or nuclear fission and you break the nucleus of the atom, it releases an extreme amount of energy. In fact, a great example of that is the sun. The sun is powered by nuclear fusion. When you slam two hydrogen atoms together at an extremely high rate of speed, the nuclei fuse and they form helium. But the amount of energy that is released from that is what powers the sun. So an experiment that tests speed in collisions, we were talking about the ramp height. You had 3 notches on the ramp. The higher you put the notch on the ramp, the faster the cart would go, harder it would hit the block, and the further the block would go. Oh, thank you. My poor boy, his ear is itchy and it's bugging him today. Chancey, stop. Andy, can you come get Chance, please? Thank you. I appreciate you. So the last question number 1, describe the difference between the independent variable or the test variable and the dependent variable, the outcome variable. Okay, the independent variable is the variable that you change. It is the variable that you are controlling. He's over there. The dependent variable is the outcome variable. So that is the result of the change that you made. So for example, if you were testing the effect of fertilizer on plant growth, the fertilizer, if you're testing different fertilizers, the plant growth is the dependent variable. The type of fertilizer is the independent variable. Now, I'm going to see if I can find my textbook. I thought my textbook was out here. So if you give me just a quick second, I will see if I can find my textbook really quick. And I'm going to give you a list of the formulas really, really quick. Okay, I will be right back. All right. Oh, thank you. Excuse me. Stop it. Stop. Chance. All right. So looking at, we're starting with, what unit is this? Starting with energy. KE equals 1/2 mv squared is one of the formulas. GPE is 9.8 meters per second squared times mass times the height. That is another formula. I'm looking for the thermal energy formula. That one is Q is equal to MC delta T, where Q is the change in thermal energy. Also, delta THE was another way that we put it, but the change in thermal energy is equal to mass times the constant, which, for example, 4.18, that would be the, I just had a brain fart. Mass times the constant times the change in temperature, T final minus T initial, and it would be the amount of energy needed to change the temperature of water, for example, by, it's 4.18 joules per gram degree Celsius, the amount of energy needed to change the temperature of water 1 gram by 1 degree Celsius. So the specific heat, there it is. So change in thermal energy is specific heat is equal, or change in thermal energy is equal to mass times the specific heat times the change in temperature. I could not remember that for some reason. And you should know the renewable and non-renewable resources. So fossil fuels, coal, petroleum, and natural gas, nuclear energy, biomass energy, geothermal energy, hydroelectric, solar, tidal harness, and wind energy. You are so welcome, Jordan. I was hoping I could help you guys as much as possible. Really, I was sad that I couldn't get through it in class, but at least, I could give this to you. I don't know if you'll need the efficiency formula, but efficiency is equal to, I don't think you're going to need this. But you do need to know what efficiency is. You are so welcome, Kaylee. You do need to know what efficiency is. So basically, the efficiency of an object, for example, gas efficiency in a vehicle is the amount of gasoline that the car uses for actual motion. So if it is 20% efficient, this was one of the questions we went over. If it is 20% efficient, that means it only uses 20% of the gas you put in the car to actually move the car. So you do need to understand that concept. I do have some videos that you can actually watch as well if you want to go over certain concepts. If you have certain activities you want to go over, most of the activities are either in live or the labs themselves are posted, and it's posted by activity number as well. I'm trying to see if there are any other formulas. Measuring speed. Speed equals distance divided by time. Force equals mass times acceleration. And I think that might be it in terms of formulas. I think that might be it. Make sure you know Newton's laws as well. Okay, I'll review what the Newton's laws are really quick. For every action, there's an equal and opposite reaction. Newton's first law, which is the law of inertia. Okay, so an object at rest will stay at rest, an object in motion will stay in motion until acted upon by an outside force. Newton's second law, the relationship between force, mass, and acceleration. Okay, F equals ma. Okay. The relationship between mass and gravity, mass is equal to, or weight is equal to mass times gravity. So if they ask you to calculate the weight of something, it is mass times gravity. If they give you a formula where you already have weight, like for example, the gravitational potential energy formula is 9.8 times mass times height. 9.8 is gravitational constant on Earth, so 9.8 times mass is weight. So it is also weight times height. Okay, so in case that comes up. And I think that's it for formulas. So I think we've gone over pretty much anything. Is it really? I've never seen Hamilton. Oh, I promised to show you guys Stitch and Angel, didn't I? All right, let me go get that really quick. Okay, so you guys already know Stitch. So he's here. But we have a new member, which is Angel. So, yes. I don't have something to print you Bluey yet. I can try. Oh, that's really funny. The musical is Why You Patch Your Civics COC. That's hilarious. Yeah, so we have Stitch and Angel together. Yeah, I saw them carrying a whole big plushie in Sam's Club, and I had to walk in the opposite direction, or I would have wound up getting it, and I can't get that right now. Yes, we have a new edition. I was thinking about bringing her to school. I might bring her to school maybe Wednesday. I don't know. We'll see. Hamilton? Maybe I'll go see it one day. I haven't been able to. Oh, the big plushie? I do want the big plushie. I really do. Hi, Jackson. Are you just getting in? Okay, now she's purring because I made her talk. So I'll bring them to school. I was thinking maybe Wednesday because I didn't want to bug people with the finals. Oh, okay. Oh Lord, the big Stitch. I'm not gonna have anywhere to put anything in my house. And now she's purring. Can you hear her? All right. Well, I'm so glad I was able to help everyone. Okay, she's talking. So so I'm really glad I was able. I hope this was really, really helpful, and I hope I was able to answer any of your questions. But it is way well past dinner time. So where did I get those? Actually, they were both gifts by my wonderful husband. He is very supportive of my Stitch obsession. You are so welcome. Have an amazing evening, everyone. And thank you so much for joining. I'm glad that I was able to help you out. And good luck. Please don't stay up too late studying. So he takes good care of me. And he's funny. He was telling jokes in the background. See you tomorrow. Have a wonderful night, everyone. Bye. See you tomorrow. Who is Appliance Corner? I have not been able to figure that out. Bye. All right. I'm going to end the stream so that I can post it so people have a chance to watch it. Aw. Well, I kind of have to. People need to be able to go back and look it over, and they can't see it yet. All right. See you tomorrow.